SN1 mechanism. As in case of aliphatic nucleophilic substitution, aromatic nucleophilic substitution reaction in which SN1 mechanism is happening contain two steps. First step is formation of carbocation. That is, this type of mechanism is happening usually in case of diazonium salts. For example, here 111N. Then the slowest step will be first step, that is formation of carbocation. Here the carbocation is like this, and nitrogen is eliminated. Then the second step is the attack of nucleophile, that is this nucleophile Y minus is attacking over here and form substituted product. Okay, so the first step is the rate determining step. So we move on to the evidences that lead to this mechanism. First of all, this mechanism is happening in case of diazonium salt. The reaction rate is first order in diazonium salt and independent of concentration of Y. That is independent of concentration of Y minus. That is our nucleophile. So, since it only depends upon the concentration of this diazonium salt, it is found that at a rate determining step there is no attack of Y minus, so that this may be the mechanism. Then the second evidence is when high concentration of halide salt are added, the product is an aryl halide, but the rate is independent on concentration of added salt, that is concentration of this Y minus. Okay. Then the next point is effect of ring substituent on the rate are consistent with the unimolecular rate determining cleavage. Okay. Then the next point is when this ortho substituents are replaced by ortho position are replaced by deuterium instead of hydrogen, there is an isotopic effect of 1.22, which corresponding to secondary isotopic effect. So the evidence for this evidence or this point can explain by the fact that this phenyl cation, that is our intermediate phenyl cation. This is phenyl cation. Phenyl cation. Okay, this phenyl cation is stabilized by hyperconjugative structure like this. That is, here this bond is breaking and this is going here and a benzene is formed. So it is stabilized by this type of hyperconjugative structure. So we can we can say this hydrogen is involving this kind of stabilization, so that the isotopic effect of 1.22 is getting. Another evidence is that if you use diazonium salt with labeled nitrogen, that is Ar N triple bond N. Here this nitrogen is labeled as N15. Okay, here, this is the normal nitrogen, and that is N14. Then after some time it is found that the reaction medium contains another compound Ar N triple bond N. Here the normal nitrogen, then here labeled nitrogen. This could arise only if the nitrogen breaks away from the ring and then returns. That is, here Ar breaks and phenyl carbocation is formed, and then nitrogen breaks away, and here, and this is nitrogen 15. So this eliminated nitrogen may recombine with this phenyl cation to form these two products. That is when it is attached with this nitrogen, then the product will be this one, and when it is attaching with this nitrogen, the product will be this. Okay. Another evidence is that if you use only exclusively this labeled nitrogen in labeled diazonium salt in nitrogen atmosphere, that is we are using N2 unlabeled nitrogen as atmosphere, then at 300 atmospheric pressure is used, then at 300 atmosphere pressure, the recovered product has lost about 3% of the labeled nitrogen, indicating that our diazonium salt was exchanging with the atmospheric nitrogen. That is, first of all, we are using this compound, and after some time, these two products are formed. Another evidence is that we are using the labeled diazonium salt with double nitrogen with free or usual unlabeled nitrogen at high pressure. Then after some time, the activity of this aromatic diazonium salt decreases at about 3% because of the exchange of this N2 with this atmospheric nitrogen. Okay. Then there is kinetic and other evidence that the step one is more complicated and involve two more steps. That is two steps. That is AR N2 plus. Then it is formed AR plus. This is N2. Then it form AR plus phenyl cation and nitrogen. Here I am writing this simply as this and this as same, but it is in bracket. This indicates that it is a tight molecular, this tight ion molecule pair. This is tight ion molecule pair then has been trapped with the carbon monoxide. Thank you.